So now let's go ahead and practice using the triangle inequality theorem. So for these first set of examples, we're going to tell whether a triangle can have sides with the given lengths and then explain. And so we know from the triangle inequality theorem, if I take any two sides, they have to, when I add them together, it has to be bigger than the third side. And so instead of checking all three, what I like to do is I take the two smallest sides, add them together, and see if it's larger than the third. Because if I were to take my 19, for instance, since it's the longest side, and add them with the others, I know already it's going to be bigger than that third side because 19 is bigger than both 10 and 7. So a quick way to check this is take your two smallest sides, so for instance 7 and 10, add them together, and we're going to check and see whether that's bigger than my longest side, which is 19. So when I add 7 and 10, I get 17. Now you look at that inequality and see if that's true. Well, I know that 17 is in fact not bigger than 19, so this is false. And so because it's not bigger than 19, this would not be a triangle. So a triangle cannot have these side lengths. Okay, let's try another one. So again, I'm going to take my two smallest sides. So my two smallest are 8 and 13. I'm going to add those together. And my question is whether they are bigger than my longest side. Well, 8 plus 13, I get 21. And now I need to look at, oops, that should be 21. Now you look at that statement and see whether that is true or not. 21 is greater than 21. Well, I know that 21 is equal to 21, but it is not bigger than 21. So this is a false statement. So that means that the answer here is also no. Okay, looking at my next one, I want to again take my two smallest sides. And so I see my two smallest sides are 2.3 and 3.1. Add those together. And I'm seeing when I add those together if that is bigger than 4.6. Well, 2.3 plus 3.1, I get 5.4. And now I need to think if this is true. Is 5.4 bigger than 4.6? Yes, it is. Since we get a true statement here, the answer here is going to be yes. Okay, go ahead and pause the video. I want you to try number 4 on your own. When you think you have it, go ahead and press play. So the answer you should have gotten here was yes. When you add 6.2 and 7, you get 13.2. And that is bigger than 9. And so that means that this would form a triangle. Okay, now for number 5 and 6, we're going to be looking at describing the possible lengths of the third side. And we're going to be using a compound inequality for that, which we'll see here in a second. So for number 5, it says a triangle has one side length of 14 and another side length of 9. Describe the possible lengths of the third side. So I have some triangle here. I know one side length is 14. I know one side length is 9. Now I want to find that third side length and describe what those possible values could be. So I'm going to go ahead and just label x to be that third side. And we have two different possibilities of what x could be greater than or less than. Either 14 is going to be my longest side, so either we could have that x is less than 14, or we could be that my side length x, my third side length, is actually my largest side length, and if that's the case, then x is bigger than 14. And so we're going to come up with two different inequalities for those cases. So if x is less than 14, then I know by my triangle inequality theorem that 9 plus x should be greater than 14. Because if x is less than 14, then that means it's going to be either my smallest or my shortest or second shortest side. And so I want those two shorter sides to add up to be bigger than my longest side. And now I'm going to solve for x here. So to solve for x, I'm just going to subtract 9 from both sides. And I get that x is bigger than 5. Now, if x is bigger than 14, that makes it my longest side. And so I know, again, from that triangle inequality theorem, that means that 9 plus 14 should be bigger than x. And then when I add 9 plus 14, I get 23 is bigger than x. So in other words, x is less than 23. So I see two different possibilities here. I see that x is greater than 5 and x is less than 23. And when we have these and statements, we do a compound inequality. And so that means when I'm writing out my answer, the third side length is going to be between 5 and 23. And so I would write that as 5 is less than x, which is less than 23. So that means my third side length can be anywhere between 5 and 23. Okay, let's try another one. So here a triangle has one side length of 12 inches and another side length of 20 inches. Describe the possible lengths of the third side. So again, I'm going to have x equal my third side. And we're going to have two cases. So either with my triangle 12 and 20 of side lengths, either 20 is going to be my largest side. So in that case, my third side is going to be less than 20. Or my third side is my largest side, which means that x is bigger than 20. If x is less than 20, then that means that my shorter side, 12, plus x should be greater than my largest side, which is 20, by my triangle inequality theorem. And so solving for x, I'm going to subtract 12 from both sides, and I get that x is greater than 8. Now, if x is my longest side, then that means that my side lengths 12 plus 20 need to add up to be bigger than x. Well, 12 plus 20, I get 32. So in other words, x is less than 32. So x needs to be bigger than 8 and less than 32. So to combine those two inequalities, I would write 8 is less than x, which is less than 32.